thing you guys should notice real quick off the top here is that what is in the title of this section? The word simple. You're erring on the side of caution. Yeah. Now, what we're going to do is we are going to work with some simple stuff today. And it shouldn't be all that bad. What I want to make sure we understand here are what are these rational functions? What do they look like? We're going to do some very basic graphing. As you can see, I've already on the whiteboards, I have two of the models that we're going to be working with. And a few of these things that we've been talking about today that when we're graphing them, each one of these are going to have specific parts that you're going to be able to identify by hand without using the calculator. Then to graph them and to get ordered pairs and stuff, you will use the calculator. So it's a matter of being able to identify some stuff. And one of the things that I like to start with when I'm looking at rational functions is to look at, well, what do they look like? Well, we write rational functions like this. F of x is going to be some polynomial divided by some other polynomial. Polygon. It's a hexagon divided by a heptagon. No. So it's going to be some polygon. I haven't done that at all today. Some polynomial divided by some other polynomial. Remember, polynomials are what we've been working on for a while. You have second degree, third degree, fourth degree polynomials. All those, they just divide themselves out. The way that the book is going to write it, it's going to be written to screw you up, though. So, they write it like this. It has nothing to do with that, but that's the way the book writes it. Yes, sir. Oh, I got a question. So the book writes it as f of x is going to equal p of x divided by q of x, where p and q's are polynomials. In other words, it's a polynomial divided by a polynomial. I think you guys like that terminology better. It's a little bit easier to look at. Now, there are a few things that you guys already know without having to get involved with this about graphs. For example, if I take f of x, oops, and let's say it's, I wanted to graph that. What is something you can tell me about that right off the bat? What can't x be? 0. -1. Very good. You're in the right realm there. You know that your denominator can't equal 0, correct? Yeah. All right. So the denominator can't equal 0, so x can't equal -1. What happens when x equals -1? What's formed? What is that called?
This.
What is this? Besides what Gal was trying to do to me earlier.
Okay.
What's that?
Undefined.
Undefined. Okay, so it's undefined, and you're telling me it's vertical. What is that when you have an undefined vertical? Yes, it's up and down. That's what vertical is, yes. All lines are straight!
That's heteronormativity for you.
You get that on Scrabble. It's like
no, it's actually a cards against
Is it just
card,
X?
and that's the only reason I know the word.
That's an awful game. That's great.
It's so awesome.
Anyway, so if you know your asymptote from a hole in the ground, you would know what this is called.
What? Just X.
A hole in the ground.
Why is that? Vertical lines.
X equals 0.
If anybody remembers what this is called, you would probably remember.
Wait, I didn't
Undefined. If something is undefined, what goes through it?
Yes.
On a graph.
Imaginary.
All right.
Oh, it starts with a letter.
All right, let's all be quiet for a second and listen to this question again. If you knew you were asymptote from a hole in the ground, you'd know the answer. Oh, you are so smart!
See, I knew it. I didn't want to.
Someone said that though. Someone said asymptote.
Oh, they did?
Yeah.
I didn't hear it.
And you're sitting here like telling us we don't have it yet.
Oh, I didn't hear it. Anyway, an asymptote. What happens with these things when you have... You've never heard the phrase, you don't know you're from a hole in the ground?
I'm from like a hot rock.
I just assumed it was an asymptote after I confirmed that it was not.
It's me, it's 12 hours. I've worked for 5 days straight. It's kind of... An asymptote. Remember when you guys had asymptotes with hyperbolas and conics, and your hyperbolas had what were called slant asymptotes?
They were crisscross. Are these?
They made you jump, jump?
Asymptote?
Remember they had slant asymptotes? Well, now we're talking about polynomials, and when we're looking at polynomials, we're not dealing with conics. Conics had curves. Polynomials we're looking at, well, all right, so these are going to have curves too. But anyway, these are going to have vertical and horizontal asymptotes. You guys have worked with finding asymptotes in the past. Before it was H values and K values. You had A's and B's and the little box stuff. Basically what you're looking at here when we're working with polynomials, you can't divide by 0. The zeros of your terms in your denominator will create asymptotes. Yes, sir?
Are these formulas going to represent the vertical and horizontal asymptotes?
Along the lines here, yes. We're good. I mean it like that, but these are 2 types of equations we're going to look at. Each one of them is going to have their own way of finding asymptotes. And it's very, very simple.
Along the lines
Okay.
of that?
Yeah, I didn't mean to
You
do
can
it.
go for that. That's pretty good.
Yeah. Straight and narrow is me.
I found it
So
funny.
here's what I want to do. I want to look at,
I laughed. I'm always laughing.
I want to look at this.
It's like I'm sure.
One of the forms we're going to look at today is this. I forget what it's actually called, but it's called something. It's a polynomial.
Starts with a letter.
Starts with a letter.
That was rude, Katie.
And
Frankly, I am hurt.
when you have equations that are written in this form, there are a couple things you're going to be able to tell right off the bat. You're going to have A, H's, and K's. We've dealt with A, H's, and K's a little bit when we dealt with shifted conics. When you had ellipses and hyperbolas, we worked with those. We had A, B, H's, and K's. Now we're going to start to get into our graphing of more of the polynomials, logarithmic, rational, radical equations that'll also have A, H's, and K's in them. And they're going to have different meanings now. Your H value and your K value are going to mean something, and you'll start to see how they work out here real easily. So when you have something like this, the vertical asymptote is always going to be at x equals h. Now, x minus h is a term. You guys agree with me on that?
Yeah.
That's why h is the 0. Think of it as the 0 of the denominator. When I put an example up here with numerals, with numbers in it, you'll see it real fast. Okay, it's extraordinarily simple. This horizontal asymptote is always going to be where set this equal to 0 and solve for x is basically all it is. All right. When you see it, when I'm saying to think of it in terms of the 0 of the denominator, when I show you the actual example, you'll pick up on it like that. I'm just talking in terms of generics right now. This horizontal asymptote is going to always be at the line y equals k. All right. What?
There's a few high and then
Oh my God, no.
I think Horace is best. No. Keep it the way. Just laughing take all the fun out of this class, why don't you?
Oh, I don't either.
No.
Where's that from?
Yeah. I don't know you were raised
Just continue. Forget about it.
Keep going.
Abbreviated horizontal row.
No, I didn't.
There's no stop.
Oh.
This-
Do you get it? They want you to put each R, which is late.
It is
That
late.
makes
They're at a
sense.
different level.
Thanks.
She's having like
I don't get it.
I'm not conforming. Take the job.
Okay.
Oh.
You get it?
Yeah, but like, that's that.
So you have your vertical asymptotes.
Oh.
Get it?
I got it a long time ago. I'm just trying not to, play into it.
Well, there you go.
Turn and stop the whole.
It seems like I'm the ringleader sometimes, though, doesn't it?
All right, now it says two verticals.
Yeah, you
What are you doing?
They tried to stop the horse play.
Boom.
So you know what, Ollie? Ollie, go for yourself and hit dodge. That'd be great.
Hey, I'll get you.
Thank
What do you make?
So as you go through this, when I look at a number, I'm looking at it numerically. What we wind up doing here is we're going to label stuff out with A, H's, and K's. All right. I want us to get in the habit of labeling what your values for A, H, and K are going to be. The reason I'm asking you to start doing it like this now is as we get into each style of function we're going to be working with over the course of the next few units, rationals, radicals, logarithmic, and then eventually we get into trigonometric ones. Every one of them have A, H, and K involved with them. And the faster you just start identifying them and writing them down, the easier it's going to be when you have to use them. In this unit, or excuse me, in this form, it's really easy to figure them out. So A is -2, K is +4. Now, Emma, this is where you're kind of asking about here. What do I do with this defined H? Well, it's basically what makes the denominator 0. What's the 0 of that term? 3. And so H is 3. Okay? If it was X plus 3, what would H be?
Negative.
That's all this guy's.
Would you actually do that, or could you just like take the 3 out? Do you have to use the X?
You should be able to look at it and tell what it is. Okay? Go ahead, Mom.
Wait, hold on. But I thought we said that it can't equal 0, and so why are we making it equal 0?
Where does, well, that's why you want it, your asymptote is where it equals 0. What can't it be, what, all right. Your asymptote for verticals is because you don't want it to be 0. Okay?
So the S.
The asymptote is where it's never going to occur, and it occurs when it is 0, when the denominator is 0. So you're finding out what is the value that makes that denominator 0.
So
that-
we're finding when it wouldn't occur.
Yes.
Okay.
Yeah, you're using weird words weirdly.
You're using weird words.
I am? Are you?
Yes. So here's what happens. When we go to graph something like this, yeah, but
Are we trying to find everything besides the asymptote, or are we trying to find the asymptote?
we're finding the asymptote because that's how you graph these.
So that's just 3, X is 3, and that's all we worry about?
Pretty much right now.
What are the other ones?
So if I want to go through this, I know that my horizontal, my vertical asymptotes, my vertical asymptote will be at X equals 3. I label it as X equals 3. My horizontal asymptote is at Y equals 4. Now I figure out how to plot this. Well, I'm not going to sit there and substitute in points all day long to figure out what's going on with the graph. So what do I do? Calculator. Now, if I'm not mistaken, most of you guys probably haven't really had to use your calculator since for graphing it all, since we did our stuff with that 6.9 where you had to make tables and all that weird things. So what we need to do is we have to reset a lot of this stuff. First thing you'll want you to do is hit second y equals to go to your stat plot, and I need you to turn off your stat plot, otherwise it's not going to work. In order to do that, you just hit second y equals, go into the option number 1, and you want to highlight where it says off. Just make sure it's on off now. Everybody okay with that? Second y equals, and just make sure it's off. Go ahead and back out.
Do we need it on for the thing we did on
Not anything for today.
Wednesday?
Only for that one we did the other day, yeah.
Okay.
Go to your window. You're going to reset your window. Your window's probably all sorts of messed up. Okay. Put it into a regular 10 by 10 window with your X and your Y scale factors to be at 1. It just makes the cleanest windows. Okay. I get to reset the, you have to clear it and then reset the RAM, so you have to do 712 and the 722, and it should go through that. But I think you still have to turn off the stat block.
Yeah.
No, it did work. Okay. I wasn't sure. This is just one way to go through it real quick. So now we're just go back to our y equals, and we're going to put in the function we just had, this rational expression. And remember how to create a fraction?
Alpha y equals.
Very good. We do alpha y equals. And what was it? Negative 2 over x minus 3. And then move to the right to get out of the fraction bar, plus 4, and hit graph. And you get that.
Hey, it looks like a street.
Now,
Say it, let's see it.
with any luck, here's probably looks like that. Yes, ma'am.
What if my, that one's not
You didn't type in something out.
Okay.
So, yeah, you notice how this is a hyperbola twisted? If you just turn your calculator sideways, it's going to look like a hyperbola you did earlier. What?
I get it.
Okay? And the reason that it's not done, it's not like the hyperbolas have done before, is because it's not a square, they're not squared out terms, the two of them squared. Yes, ma'am. Window is all messed up. Reset your window. Reset your clock. Your graph wasn't highlighted. You just turned that graph off. So what we're looking at here, guys, is this gives you a rough sketch of what it is, but the requirement that I'm asking you guys to do is that I need you guys to plot two ordered pairs of both sides of the curve. And to get those ordered pairs, all you have to do is press your table. Go to your table, and yes, you are going to have some crummy numbers. It's not a big deal. They should be fractions and whatnot. All you have to do is just give, or some of them might be okay. You just write out two sets of ordered pairs on both sides of the curve and call it a day. The error is your vertical asymptote. Because can you divide it by 3? Or can x be 3 in this case?
Oh, no.
Because you want to divide it by 0.
Wait, so what, you just take like, and you got your homes?
You want 200, because you have to figure that out. Notice in this case, where's your vertical asymptote? It's at 3. Is it are 1 and 2 on one side, 4 and 5 on the other?
Does this have to do with the
Yes, ma'am.
It's because we
You
can't
should
believe
be
you
able
don't
to
have
really
from zero.
dots.
Since you can't have a function from zero.
That's all it is. Okay?
Wait, how are those ordered?
So can we say 4 and 2 and 2?
Ladies and gentlemen, these are ordered pairs right off the table. That vertical asymptote is separating both sides of the curves, aren't they?
Yeah.
It just matter of writing out your plot points. That's all it is, guys.
So
Yes, sir.
you just write out like 2 and 6 and 4.
Yes, sir. What's up?
Are those just two you picked, or are those the?
Those are ones that show up that are clean. Not always you're going to have clean ordered pairs. That's all. So if x is 1, y is 5. If x is 2, y is 6. If x is 4, y is 2. If x is 5, y is 3. Yes, ma'am?
So you said you wanted 2 points on each.
On each curve, please.
And do you want them like if we can put them, but do you want them like listed too?
It would be okay if you just list them. It's not a big deal.
And so if we list them, should we do like first and then second?
When you're graphing, just put 2 here. And put 2 here. It's fine. Yes, sir.
How do you know the points are on the curve? Because this is the equation for the asymptotes, right?
No, it's the equation of the curve of the actual rational function. This is the graph of this equation. That's what this equation looks like. The asymptotes are part of that equation.
That's not what we did for hyperbolas earlier, is it?
No, remember hyperbolas, there was a different thing, because they were conics. They had x squared and y squared terms. This is rationals. These are polynomial divided by polynomial.
What makes that different?
Do you see square terms?
But then how do you still get hyperbolas?
Add numbers. They're inverse relations, because you have variables in the denominator. Think of 1 over x. 1 over x is it's a curve. Same idea. Try another one. Oh. For some reason, this got out of sequence here. Yeah. Look at another one here. I'm not even worried about graph paper here, to be honest with you. I mean, if you want to use graph paper, you have it. I want you guys to try one more. Remember, you need to identify horizontal and vertical asymptotes, fill in where your curve is going, and give me 2 sets of ordered pairs on both curves. It should be really, really, really easy.
Where does the asymptote lie?
The y-intercept.
Think of it this way. Your asymptote, how do you define it? Right. I forgot. When you're looking at the curve itself, as things are being divided out, they're always going to be approaching some value. The value that they're going to be approaching winds up being whatever that constant is at the tail end of these types of functions. Always. It's just one of those weird math things that happens to a curve. That's where they come up with the horizontal asymptote. Horizontal asymptote is a little bit more difficult to define, whereas if you have that 0 in denominator, bad. That's easy. The horizontal asymptote, something's always approaching it. You can't really get to it, but you're getting really, really close to it. It's like, I'm not touching you, I'm not touching you, I'm not touching you, I'm not touching you. And I called your sister Gretchen today, and I apologize.
I'll tell her that
I'm just
you don't regret that because then she'll laugh.
That's
Tell her you did. She'll laugh.
How does A help us?
The A value eventually is going to help you decide what sides things are going. Notice how it's positive and it's first, third. We did the other one here, it's negative, it was second, fourth. So I'm hoping that you guys understand.
What's A then?
The A value, like I was just saying, hey guys, I hope you might have noticed this. See how A in this case is positive? Our 2 curves were bounded basically first and third quadrants. When the A value was negative, where were they? Second and fourth style? Because what your asymptotes really are, the asymptotes are the shifted origin. Okay? So,
Oh, that makes sense.
that's all they are. Yes, ma'am?
When we're writing coordinates,
Yeah.
do we like go to the graph and use like the weird decimal ones?
No. Just go right to your table. Yeah, you want to go to your table. I mean, obviously some graphs you're going to have better numbers than others. Just if you want to get the habit of using the ones that look clean, that's all it is. And I'll leave it up to you guys to plot points. That's the easiest part. All right. Now let me show you the other style. The other style looks a little bit different. Y equals AX plus B over CX plus D. The difference between this style of the rational versus the one we were just looking at is that there's no H and K in this case. All right. You wind up with first degree polynomial divided by first degree polynomial. So it's a little bit different. Now, in order to figure out your horizontal and your vertical asymptotes, your vertical asymptote, you still find it the same way. Your vertical asymptote is going to be at the 0 of the denominator. All right? It'll be the 0 of the denominator. What makes that denominator 0? What's the x value? So basically what you're doing is you're taking whatever it is that's cx plus d, instead of equal to 0, to solve for x. That's what you're doing for that. When you see it numerically, it's that fast. Okay. When you go for the horizontal asymptote in this case is going to be y equals the fraction of the leading term coefficients. A over C. Every time. Yes, sir?
The vertical asymptote is x equals negative d over c?
Yes, sir.
Okay.
Okay. So numerically, well, let me write it up on the board here
Do
too.
we use this for like different stuff or like same thing but just different ways to do it?
No, because you're going to have the two forms of the equations. They're going to look like this form or they're going to look like that form.
Oh,
So there's two ways of doing it. Yeah, like Clay was saying, the x equals the opposite of d over c. Now, if I show you this numerically, it's so fast. It's very, very simple to see here. Let's say you have y equals 2x minus 1 over 6x plus 4. This model, or I don't know, model, this function doesn't look like AH's and K's. It's just monomial, God bless you, or not monomial, it's first degree polynomial divided by first degree polynomial. Okay. When you have that, you know your vertical asymptote is going to be at 6x plus 4 equals 0.
negative 6, 4 over 6.
Negative 4 over 6, otherwise known as negative 2/3. It's the same idea. You have a term, what's at 0? That's all you're doing. The denominator is a term, find it 0. Okay. And then your horizontal asymptote would be y equals 2 over 6, otherwise known as 1/3. Now, I set you guys up with the problem that you wind up having to simplify both fractions. Sometimes you do, sometimes you don't. It's just the roll of the dice, if you will. Depends upon the problem. But it's very, very obvious the difference between the two equations themselves when you're looking at them as far as homework problems. Which rules do you follow? Okay?
And then when we put this stuff in this calculator, we
Yeah,
get the same graph.
same idea with the graph. The graph is going to look, it's still going to have that the two quadrant looking hyperbolas, the two curves like that, depending on what they are. You plot your asymptotes. This one you will wind up with some funkier looking asymptotes sometimes, but if you know that negative 2/3 is less than 0 and bigger than negative 1, you're fine. Just plot it. X equals negative 2/3. Y. And then it's just a matter of going right to your table to put it in the calculator.
Yeah.
It's not difficult to do this. Okay. The tricky part is just labeling out what your asymptotes are. Okay? Yes.
Wouldn't it be negative 1 for you? Because the general equation is plus 1, and then the summations and times.
I'm just looking at the coefficients. I'm looking at the actual coefficients up front. That's all I'm looking at. Okay?
Yeah.
And the A is positive on this one, so it's first and third.
I think so. I don't remember off the top of my head.
So then I just want to put it in.
You just put it right in your calculator and go. It's that fast. Once you identify asymptotes, it's the calculator from there. Okay? Let me show you another one very similar to that. See if you can pluck it out.
Ordered pairs, right?
Yes, sir. Same exact stuff. If I'm looking at this, I'm not going to worry about domain and range quite yet.
Oh, boy. We will,
We will.
just not yet.
Yeah. The domain and range stuff, I usually wait till section 9.3 to start getting into domain and range because that's when it becomes a little bit more important. This isn't so bad, and we'll revisit it next week as well. So if I have y equals the fraction x plus 1 over 2x minus 4, does everybody agree that it's not this form, but it's this form?
Yes.
What is the obvious way of telling?
And there's an x on top.
There's an x on top.
And there is no one.
There's also no, the x on top is pretty much the biggest obvious thing you have there. Okay. Now, when you go through this one, your vertical asymptote
2.
will be at 2x minus 4 equals 0, and you get x is
2.
2.
2.
2.
Ollie.
Add 4 divided by 2. Okay. Your horizontal asymptote is where? Where's your horizontal asymptote then?
1/2.
1/2, good. Could you answer that in the calculator?
Yes, I can.
You start.
Then do your homework.
Don't flip puppies.
About finals. Domain and range.
Don't kill finals.
Don't worry about the domain and range. They ask you about it. Don't worry about it. We'll talk about that on Monday because it's a little bit more important when we get into 9.3. I have graph paper if you want to use graph paper. You really don't need to if you don't want it. I have plenty of it. If you are so inclined that you want to use graph paper, you only need one piece for those last 6 graphs. So if you want one, I'll just leave them. I'll leave them with Mr. Alvarez. He'll get them to you.
I want graph paper when it's too dark. Because then I can
Told you this
see
is
what
simple.
I guess just draw like
Huh?
giant. Alright.